This SciShow video is a companion episode to a new series about conservation produced by us for BBC Earth.
Fish have a big dam problem. Many species need to swim upstream or downstream to feed or spawn. And along most rivers, those passages have been blocked by one of the thousands of dams humans have built to generate electricity and to control flooding. Don't get me wrong. Dams are great at those tasks. They're not all bad. But we need to help fish get from point A to point B when there's a giant wall of concrete between them. Scientists and engineers have come up with some pretty wild ways to do that, including a certain fish cannon you may have seen go viral on social media a few years ago. It is a real thing. So let's take a look at a few creative ways they are tackling the dam problem and getting fish where they need to go. One of the most common ways to get fish across dams is a fishway, a series of small steps that fish swim up one at a time. Conventional fishways take a bunch of different forms. The most basic ones look like a series of pools or a ladder. Unfortunately, one thing that most of these designs have in common is that they suck. In 2011, researchers at Concordia University in Montreal compared the effectiveness of fish passage methods across 65 studies dating back to the 1960s. They found that only about 25% of non-salmon fish successfully used fishways to get over dams. Even in the best-case scenario, they showed that conventional fish passage efficiency tops out at about 75%, but only for salmon-type fish, which is okay, but for imperiled fish like Chinook salmon, getting as many individuals upstream as possible is important for conservation. Why are fishways so ineffective? Well, fish are finicky. It's tricky to get them to find the entrance to a fishway and motivate them to make the entire climb. Like many animals, they use a bunch of different signals like water flow and temperature to choose where they want to go. If the signals aren't right, fish might not find the passage at all or get cold feet or cold fins and swim back down the fishway. For example, a 2013 study by the US government showed that just a few degrees difference in the water temperature at the top of a fish ladder compared to the bottom can slow fish passage speeds from a few hours up to 4 days. That's a big difference when you have a tight reproductive schedule you need to meet. Enter the salmon cannon, a fishway that does the climbing for the fish. If you don't remember this thing, it's probably because you don't spend all your time on the internet like I do, which is great. The idea is pretty simple. Instead of putting the onus on the fish to climb up the ladder, let's just launch them up there ourselves. It starts when a fish swims into a loading area that connects to a long, flexible tube. Inside the tube, every meter or two are misters to keep everything wet and slippery, which is how fish like it. The fish's body blocks most of the airflow through the tube, so pressure builds up behind them until, whoosh! In less than 10 seconds, they get launched and land hundreds of feet upstream. But as bizarre as sending fish on a daredevil jump might seem, the cannon appears to be pretty safe. Only 3% of launched fish show any signs of injury, like small injuries to their fins and eyes, which means that the fish are in good shape to continue their journey. That said, the salmon cannon isn't perfect. The air pressure can only build up if the fish is big enough to momentarily block the tube. Fish that are too small might not get launched fast or far enough and may even come back down the world's weirdest water slide. With the aid of computer imaging, the salmon cannon folks are smoothing out these quirks. Recently, scientists at the Pacific Northwest National Laboratory piloted an update that sorts fish based on size using an algorithm that analyzes photos taken when they are in the cannon's loading zone. Big fish get launched by the cannon and smaller ones get bypassed. It's like a water slide. You have to be this thick to get shot up out of a cannon. Early signs are positive, with the algorithm correctly separating big fish from small fish about 3 out of every 4 times. Not perfect, but it's definitely a start. AI, it's got its flaws. In the future, the researchers hope to fine-tune the program and set up a battery of cannons, each calibrated to a different size range of fish, so that everyone can enjoy a ride on the salmon cannon. So far, we've focused on fish making an upstream migration, but a lot of migratory fish, like eels, actually travel downstream instead, sometimes multiple times over the course of their life. Unfortunately, even with gravity on their side, migrating downstream isn't necessarily safer or easier for fish. One of the reasons for that is hydropower dams. There are more than 2,700 of them in the US alone. Hydropower dams use fast-moving water to spin the blades of a turbine and power a generator that creates electricity. When fish move downstream, which means they're following the water flow, they can accidentally stray too close to the turbines and get sucked in by the strong current. Researchers in Austria have a potential solution: an electric fence called the Flexible Fish Protector. Patented in Europe, the fish protector works on a pretty simple principle. Fish don't like to be electrocuted and will swim away if they get too close to the source of the electricity. By using electricity in combination with a more conventional physical barrier like a cable fence, the fish protector folks hope to not only keep fish away from the turbines, but also direct them towards a safe bypass through the dam. The neat part about this technology is that it takes something that makes engineering a fishway difficult, the fact that fish use multiple cues to guide their movement, and turns it into a strength. With 2 signals instead of just one telling fish what to do, they tend to be super motivated to avoid the turbine inlet when the fish protector is deployed. Success rates are as high as 99.5%, meaning it outperforms just steel cables alone. Fish ladders, salmon cannons, electric fences, a lot of human brainpower has been dedicated to getting fish from here to there. Although some dams have been removed in recent years, our ever-increasing need for energy, especially renewable energy, means that a lot of dams aren't going anywhere anytime soon. So maybe the big question isn't whether dams and migratory fish can coexist, but what else we can do to make that a reality. And if it involves something destined for a viral video like the fish cannon, so much the better. If you watched this episode and were fascinated by the innovative technology being used in animal conservation, you might like this new series about conservation produced by us for BBC Earth. Save Our Species explores the incredible and unexpected tech-based approaches being tested to help protect wildlife, including drones that catch whale snot, ferret vaccines shot from ATVs, and even cryogenically frozen DNA. You can watch the series by following the link in the description.